Welcome to a journey into the heart of web performance. In today's video, we are diving deep into the world of LCP, demystifying what it is and why it matters. Whether you are a seasoned developer, a technical SEO specialist, or just starting your web journey, understanding LCP is the key to unlocking a faster, more user and SEO-friendly experience. So grab a seat and let's explore the exciting world of Largest Contentful Paint and why it's your website's secret to success. Largest Contentful Paint, or LCP, is one of Google's core web vitals. Those vital signs of web health that can make or break users' experience. It's introduced by Google and checks how quickly the page loads. Now let's dissect the definition. LCP measures the render time. Think of it as the show time for your web page. It's the time it takes from the moment you hit that go button until your page starts showing its content. But what's so largest about it? LCP focuses on the largest image or text block. This image or text must be visible within the viewport. The viewport is like the window into your web page. And the last but not least, the timing. LCP is measured relative to when the page first started loading. Well, here is the golden rule. Websites should aim for an LCP of 2.5 seconds or less for at least 75% of their page visits. That's the sweet spot where your users get a fast and smooth experience on your website. But why 75%? That's a great question. The 75% mark is like a balance point. It means that for the majority of your visitors, they're getting a speedy experience, which is what we all want, right? Of course, we'd love it to be 100%, but in the dynamic world of the web, a 75% benchmark is often more realistic, and it still ensures that most of your users have a fantastic experience. Now that we know what LCP is and why it's essential, let's talk about how we measure it. And for that, we've got two key types of tools to help us. First up, we have tools that report lab data. These capture information in a controlled environment with predefined device and network setting. It's like the lab of web performance testing, where we can see how things behave under specific conditions. On the other side, we have tools that report field data. These gather insights from actual users visiting your site in real-world conditions. Think of it as your website real-world performance report card based on how it performs for your visitors out there. Here are some lab tools you can count on: Chrome DevTools, Lighthouse, PageSpeed Insight, and webpage test. These tools help you perform experiments in a controlled setting, just like scientists in a lab, to see how your website's performance measure up. Conducting lab measurements is the most effective method to assess feature performance during development, long before they are made available to users. But what about the tools for field data? Some of the key players in this category are Google PageSpeed Insights, Search Console's Core Web Vitals Report, and Chrome User Experience Report, or CRUX. These tools give you the real scoop on how your website performs, offering insights from the people who matter the most. That means your users. Now you might be wondering, what exactly does LCP take into account? Let's break it down. Let's bring our explanation to life with a hands-on example, a simple web page. We've got a headline, some text, and the star of the show, our beautiful image. This image could be the Largest Contentful Paint, or LCP. And now here's a web page featuring an SVG image with a single image element. that also could be LCP. Our page showcases an SVG image, and within this SVG, we've got a solo image element. This image element could be an LCP element. Now, here is a web page showing a video with a poster image. Before the video starts, there is something special, the poster image. This poster image is like a sneak peek, a glimpse of what's to come. It sets the stage for our video's performance. As the page loads, LCP kicks in, measuring the time it takes for the poster image to make its entrance within the viewport. But why is this poster image so important? Because it's the first impression, the visual teaser for your video. Now let's explore another intriguing example. This time we have a web page featuring an element with a background image loaded through the URL function. As the page loads, LCP steps in, measuring the time it takes for this visually significant background image to load and become visible within the viewport. Before we dive into our next real-world example, let's understand what a block level element is. In the world of web design, elements can be categorized as either block level or inline. Today, we are focusing on the block level ones. A block level element, as the name suggests, always starts on a new line. It's like hitting enter on your keyboard when you are typing. The browsers automatically add some space, a margin, before and after the element, which helps create a clear separation from other content. As if that's not distinctive enough, here's the defining characteristic. A block level element always takes up the full width available. It stretches out to the left and right as far as it can, making it a great choice when you want to create structure and layout in your web design. Two commonly used block elements are the P element and the div element. You might be familiar with the P element for creating paragraphs and the div element for creating divisions or sections in your web content. By the way, here are full list of the block level elements. With this understanding, let's explore a practical example involving a block level element and see how it influences Largest Contentful Paint. Here is a web page featuring a block level element containing text nodes. Take a look at this P element that is a block level element and it contains more text, so it could be a candidate for LCP. Now a web page that shows the auto-playing video. As the page loads, it features a video element with the autoplay attribute. This means the video begins playing without any action from the user. In the context of autoplaying videos, consider this. The very first frame you see, which essentially functions as an image, can potentially become an LCP candidate if it's not only within the viewport but also happens to be the largest element. In our next example, as the page loads, it features an animated GIF element. These GIFs are known for their captivating motion and are often used to add charm to web content. The GIF you are about to see is an animation that plays automatically. In the case of animated GIFs, this first frame is significant and could be your LCP candidate. Now let's discuss elements that, while they may appear on a web page, are not considered as candidate for LCP. These elements fall into the category of non-contentful, meaning they don't significantly contribute to the user's experience or understanding of the web page content. First, we have elements with zero opacity. These are elements that are completely invisible to users because they have no visual presence. In other words, they are hidden from view and don't convey any meaningful content to the user. Next, we come to elements that fill the entire viewport. These elements are often seen as background rather than main content. They're expansive, taking up the entire screen, but they are often decorative or stylistic in nature, rather than being part of the primary content the user interacts with. And finally, there are placeholder images, often referred to as dummy images, or other images that may not accurately represent the actual content of the page. These images are typically used during web development as temporary stand-ins. Since they don't reflect the real content users engage with, they are not considered contentful elements and thus not LCP candidates. But why is it important to understand these non-contentful elements? It's because LCP measures the loading time of significant contentful elements that contribute to the user experience. Elements like those with zero opacity, full viewport background elements, and placeholder images, while they might be part of the web page, don't significantly impact the LCP measurement. Now let's delve into how we determine the size of an element for LCP. When LCP is being measured, it doesn't consider the entire element. Instead, it focuses on the part of the element that's visible to the user on the screen, or viewport. This ensures that LCP captures what the user actually sees and experiences. If any part of the element extends outside of the viewport, that portion doesn't count toward the element size in the LCP measurement. So only what's within the user's view matters. Now, when dealing with image elements, things get interesting. If an image has been resized from its original size, often referred to as the intrinsic size, the reported size for LCP is the smaller of two measurements, the visible size or the original size. If images have been significantly reduced in size, the reported size is limited to what's actually displayed, ensuring accuracy in LCP measurement. However, in cases where images have been stretched or made larger, their original sizes are reported. Now, when it comes to text elements, the process is a bit different. For text elements, we don't consider the entire space they occupy. Instead, we focus solely on the size of their text node, which is essentially the smallest rectangle that encompasses all the text within the element. But here is something important to note. For all elements, including text, we don't include any margin, padding, or border set through CSS in the LCP measurement. These aspects are excluded, focusing especially on the content itself. Now, imagine you have an element that's currently the largest contentful element on your page. But what happens if that element disappears from the viewport? Surprisingly, browser will continue to recognize it as the largest contentful element, unless of course a bigger element comes into view. But here is where it gets even more interesting. As soon as the user interacts with the page, whether by tapping, scrolling, or pressing keys, the browser makes a conscious decision to stop reporting new information for LCP. This is because user actions often lead to changes in what's visible on the screen. For example, when you're scrolling, you'll change the viewport. Now, let's explore another crucial aspect of LCP, where the rendering of elements takes place and how it impacts what gets included in the LCP measurement. Now, let's explore another crucial aspect of LCP, where the rendering of elements takes place and how it impacts what gets included in the LCP measurement. Consider images that are initially rendered off-screen and then make their way into the viewport as the user scrolls. What's interesting here is that these images may not be included in the LCP report. Conversely, there is an important point to note. Elements that originally appear within the viewport and are subsequently pushed down moving out of view are still included in the LCP measurement, and they provide data based on their original in-viewport size. Now, let's talk about a fantastic tool called PageSpeed inside your secret weapon for understanding LCP. Just go to this address. This tool comes with two super useful sections. At the top, you'll find Discover what your real users are experiencing. Here, you get insights into what your actual users are going through on your site. But if you need to diagnose performance issues and go deeper, scroll down to Diagnose Performance Issues. A quick tip: if you have access to the top section or Chrome user experience data for your website, pay close attention to what real users are experiencing. It's like having a treasure trove of insights at your fingertips. In PageSpeed Insight, you can access up to 4 different Crux datasets. Mobile data for the specific URL you are analyzing, desktop data for the specific URL, mobile data for the entire origin or entire website, and desktop data for the entire origin. LCP is not the same for every page on your website. It can be a bit different, and guess what? It also depends on how people discover and browse your website. Think of it this way. Home pages are like the first stop for new visitors, and they often load a bit slower because they start from scratch without any cache data. Core Web Vitals are like health checkup for your website. They help us pinpoint if an LCP issue is specific to one page or a widespread problem. Additionally, they assist us in identifying which devices may be facing LCP challenges. Fantastic! In another video, we are diving headfirst into optimizing LCP. So stay tuned and don't miss out on this golden insight. We are here to help you make your website's user experience even better. Until then, take care and happy optimizing.